guys, welcome to today's class. Now in today's class we are going to look at something that is very important. Now if you look at the world around us, the board marker, the car we drive in, our handsets, and even the fan, now it's composed of matter, because we said matter is anything that has mass and occupy space. Now if matter is anything that has mass and occupy space, now that is to say that everything that we've listed are what? Matter. Now if you zoom in closely, you discover that this matter comprises of other substances in them. Now if you zoom in a billion times, you discover that there are other substances that are present in them. So in this lecture we are going to look at the concept of what? Atom. The historical development of atom, how atom came into, or the history of atom, like some scientists that talked about the discovering and everything to describe the nature of what? Atom. Now scientists of old were searching for the universal stuff of the universe, that is to say, what is the universe made up of? And these scientists proposed different philosophies, or let's say these philosophers proposed different philosophy as to what the earth or the world is made up of, the universal stuff of the universe. Some said that the world is made up of what? Numbers, and that is the Pythagoras school of thought. Some said it is made up of fire, because fire can consume everything, while some said it is made up of water. Some said it's made up of sand, because everything that comes must surely go or decay to sand. These were various beliefs by various philosophers. Now there's a particular school of thought that did a tremendous work and a notable work in what? In chemistry. And that is the atomism school of thought that was pioneered by who? Democritus. Now Democritus believed that the atom is made up of small uncuttable units, or that the element is made up of small uncuttable units called atom. The Democritus school of thought believes that an element comprises of small uncuttable units that are called atom. For instance, let's say you have this marker. If you can divide it, now there's a particular point that you divide it to that you can't divide any further. Or let's say a piece of cake. When they are giving a cake in, let's say, a ceremony, something happens. They share the cake into bits. Or let's say, have you taken home Holy Communion cake before? Holy Communion bread. The way they used to, in some churches, the pieces is very small. Now, according to Democritus, there will be a way that you divide it to, or an extent that you divide it to, that it won't be what? Divisible again. So he proposed the law, and he proclaimed that by convention there is good and bad, there is hot and cold, and there is order, but in truth there is atom and void. Now what he meant by this statement is, in life there is good and bad, there is hot and cold, and there is atom and what? Void. That is to say that when you cut these particular elements or substances into simpler substances, you cut it to an extent that you won't feel anything inside again, and it will be what? Empty. That is what? Void. There is nothing inside again. You just cut, is what? An empty space. But there came the rising of another great philosopher, which is the Aristotelian philosophy. Now Aristotle and Plato said that there can never be void. That there can never be what? Void. That Democritus' idea of what the atom is wrong. Hence, that theory or that belief of what the atom is was debunked for about 2000 years. So that was how atom just went like that. The theory of atomism went like that on what? On talked about for a period of about 2,000 years. It just died like that. Now, it was not until the 18th century, precisely 1807, 1808, that John Dalton gave the atomic theory. It was not until 1808 that John Dalton gave the atomic theory. Now, this is John Dalton. Now, who is John Dalton? John Dalton he came from a very poor family. He is the son of a weaver. That means somebody that weaves clothes. And his father was not able to afford the school fees. So he learned under some people like that. Those are as for what? History. But you should all know that John Dalton was what? Was poor and broke. If you want to put it that way. He was poor and broke. Are we getting it? He was the son of a weaver. Now, John Dalton was a school teacher. He was a scientist. And he did so many work in the scientific field of study. Now, John Dalton proposed the atomic theory. This is where our interest lies, the Dalton's atomic theory. Now, according to John Dalton, he said that the atom comprises of small indivisible, or an element rather, comprises of small indivisible particles called what? Atom. The Dalton's atomic theory states that an element or a substance comprises of small indivisible particles or uncuttable particles called atom. Now, this was in accordance with the Democritus school of thought. Now, secondly, he stated that matter can never be created nor what? Destroyed, but can be transformed from one form to what? Another. And this serves the basis for what? The law of conservation of mass. Thirdly, he stated that atoms of the same elements are alike in all respects and differs from atom of every other element. He stated that the atoms of the same elements are alike in every respect and differs from the atom of every other element. Let's say what you see there is atom of oxygen, and here is atom of what? Hydrogen. The atom of oxygen is different from the atom of what? Hydrogen. But all atoms of oxygen, no matter the locations, are what? The same. So if you bring an oxygen from Lagos and an oxygen from Amasoma, they are what? The same. Because the Dalton's atomic theory states that the atoms of one element are alike in all respects and differs from the atom of every other element. But this was what? Debunked by what? The idea of isotopy, whereby an atom has the same atomic number but different mass number. Atoms of elements have the same atomic number but different mass number. Let's look at hydrogen, for instance, has one atomic number, one mass number. Deuterium, two atomic number, one atomic number, two mass number, and tritium, three mass number, one atomic number. Now, these atoms are atoms of the element what? Hydrogen. These three atoms are atoms of the element what? Hydrogen. This is protium. This is deuterium. And this is tritium. They are all atoms of hydrogen. So, with the Dalton's atomic theory, it means that all of these atoms ought to be the same. But that idea was debunked by what? By isotopy. Because these are atoms of the same element, and hence they have different what? Atomic masses. And therefore one is heavier than the other. For instance, tritium is heavier than deuterium, and deuterium is heavier than what? Proton. So they are not the same in all respect. So that debunked that what? Darwin's atomic theory, which states that atoms of the same element are alike in all respect and differs from the atom of every other element. Is that clear? So atoms of the same elements are not what? Alike in every respect. Isotopy disproved that. Now, the idea of isotopy is something that we discuss in what? Our next class, or let's say in further classes. But just know that this principle was debunked by what? Isotopy, or the idea of isotopy. So that was the third theory. Now, I believe by now we should be able to give the discrepancy between the scientific methods. Now, we said the theory is subjected to further experimentation, and if it is found to be true, it becomes a law. But if it is not found to be true, then it is what? Debunked or rejected. So a theory can also be what? Be subjected to further experimentation. So this theory was subjected to further experimentation, and it was what? Debunked. So it doesn't stand the test of time. We've stated the first one, that every matter or every element comprises of small indivisible particles that are called atom. 2, that matter can never be created nor destroyed, which form the basis for the Antoine Lavoisier's conservation of law of conservation of mass. Then the third one says that atoms of the same element are alike in all respect and differs from the atom of every other element, which was disproved by what? Isotopy. Because these are all atoms of hydrogen, but they differ from each other. So that principle do not, or that theory do not stand the test of time when it comes to what? Isotopy. Is that clear? Yeah. Now, the fourth one states that when atoms combine, they do so in simple whole number. When atoms combine, they do so in simple whole number. Now, we are going to prove that later on. The theory that states that matter cannot be destroyed nor created, but can be transformed from one form to another, has also been what? Disproved. Now, it was disproved by what? Nuclear reaction. Although this is true for ordinary reaction. Although this is true for what? Ordinary reaction. But when you come to nuclear reaction, this does not what? Happen, because in nuclear reaction, the nucleus of atom breaks, and that is called what? Nuclear fission. The nucleus breaks to form other smaller atoms. For instance, uranium-235 may break to form even more smaller what? Atom. Uranium has atomic number 92. If it breaks, it will form atoms with what? With smaller atomic number. So that theory could not also stand the test of time. Now, there's another theory that says that when atoms combine, they do so in simple whole number ratio. When atom combines, they do so in simple whole number ratio. Now, when this is also true for normal reaction. This holds true for normal inorganic reaction. But when you come to organic chemistry, whereby atoms like polymerization occurs, like different hydrocarbon chains join together to form larger molecule, in that case, you cannot actually find the what? The simple whole number ratio in which that the atoms are what? Combined. Now, the other one says that an atom A and B, let's say two atoms A and B, can combine to form more than one compound. Two atoms A and B can combine to form more than one compound, C or D. The fifth one says that compounds are formed by the arrangement and the rearrangement of atoms. That compounds are formed by the arrangement and the rearrangement of atoms. This holds true. When atoms combine, a compound is what? Formed. For instance, let's say you have H2 plus O2. This combine to give us H2O. So, two atoms, let's say these are different atoms combining to form a what? A compound. So, whenever two atoms come together, they form a compound. Now, moving forward, from this Dalton's atomic theory, 3 laws were deduced by different scientists to explain what happens when these atoms work